So we have a particle in a box, and this length is a, and at this point v is infinite. So the particle will be inside, it will not tunnel through, and we know that for particle in a box, for nth energy eigenstate, the wave function in position space looks something like this. Here n is 1, 2, 3 and so on. And we need to verify that this uncertainty holds for every state. So we need to start with expectation value of x. We write this for nth state. Can always exploit the identity and something like this. This will give us by a prime and sine square times a. Cos two yes. So this is these integrals are from 0 to a, so this will be a square upon four minus, okay, we can do the integration by parts here, and what would that give us? Give us, okay, this is x prime integration of cos is going to be sin when by divide by 1/5 minus, this is from 0 to a, minus a ds prime by 1/5 sine when pi x prime divided by a. So in the first term, if we put instead of x, if we put a here, it will give us sine 2n pi. Sine 2n pi equals to 0. And otherwise also it will be 0. So this term will be 0 in both the limits. So now we need to and this negative here, this negative here, positive. So 4 plus pi. Integration of sine will give us negative cosine when a by a by 2n pi will cancel, and we will have minus cos 2n pi minus 1. Cos 0 is 1. Okay. Cos 2n pi will always be 1. No, it will not always be 1. For 2n pi is even, so it will always be 1. So this will give us 2. And this will always be 2. A by 4 minus a. Okay, I think there is an issue. Okay, so this will be plus 1. This entire term will be 0. And I think I made a mistake here. This will be plus a squared by 2. So average value of x for any state for particle in a box. This is a by 2. Okay, fine. Okay, so what can we say about square? So that would give us again 2 by a. So a square sine square cos 2 minus cos 2 cos can make it like this. By 3. Okay. So do integration by parts. Will this give us? This will be 1 square cos 2 5 minus 1 square Okay, so when we supply with A, it will be sine 2 and pi. So this is 0 for both the cases. And we now move to the next part, which is again, if I do integration by parts, what will I have? I get A by n pi outside, and it will give us prime. So sine it will be n pi x prime by A to A divided by 2n pi. There will be minus 1. This is equal to A. Right one. The minus differential will be x prime, and remaining part is integration of cosine, which will give us sine again here. This will give us A by 2 pi square Okay, so this term will be cos 2 pi, which is 1, cos 0, that is also 1, so it will be 0. And for this, how do we move forward? This term, when we do this, so this integration will be cosine, and it will be from 2n pi minus cos 0, which is again 0. So this integral turns out to be 0. And this is a square by 3. Okay, so sorry. So this is not 1 minus 1, it will be 1 minus 0. So this will be 1, and this part will cancel out. This term will be 0. Okay, so let me just write this again. So this will become a times minus a by n pi. This will be cos 2n pi. Minus 2 by just 2 pi square by square. So average value of x square is a square by 3 minus a square by 2n square by square. So the variance in x is square minus x whole square. So we can write it was square by 3 by 2n square pi square a by 2, so this will be square by 4. So this will give us a square by 12 minus a square by 2n square pi square. Right? Okay, fine. In similar way, we are interested in finding the momentum as well. So for that, we need to do this. There is root 2 by a sine by spine by a square y prime 2 by a sine okay, right. The derivative of sine will give us cosine. We'll have return a by n pi. Okay, so 2h bar Okay, so this will give us cosine, and since cosine is an even function, it will give us 0. So average value of momentum is 0. Okay. Then our interest will be p square. So well, we can first try to calculate this part in advance. What will be the double derivative of sine n pi x prime a, which is equals to x prime of sine of a x by a multiplied by n pi a. We do the derivative again, we will again get the n pi by a. Square it, it will be minus sine n pi x prime by a. Okay, so now it will be p square is again what we write 2 by a, so x prime sine pi x prime and a. There is h bar square on I square multiplied by sine n pi x prime upon a, which will give us minus 2h bar square a, so a x prime. Yeah, so there is one term here. There is -1. Okay, so this will become positive, and this will be sine square a square pi square a square instead of this we can write square. So we write this will be 1 by 2 plus 3. Okay, so after integration this will become sine, and it will be 2n pi minus sine 0, which is equals to 0. So after integration this is 0. We are only left with this term, which will be a by 2. So 2n square pi square h bar square divided by a cube 2a by 2 is nothing but n square pi square h bar square square. Okay, so variance in pi square is a square pi square h bar square divided by a square minus p equals 0, that is 1 square pi square h bar square upon a square. And when we multiply delta x square and delta p square, we get square by 12 minus square by 2 n square pi square is 1 pi square where n is 1, 2, 3 and so on.